So it's
Right.
not super sophisticated on what's there, coming up with a way of being able to mass produce it really cheaply. You just kind of go through, look at that bill of materials. It's all, again, it's the actuators,
Yeah.
that's where all the cost is.
Hey, y'all, it's Dr. Know-It-All. It looks like we are having a romantic dinner together here because both of us are kind of mood lit tonight, but I'm coming to you from Santa Barbara. Scott is coming to us from your house in Florida.
Florida, yep.
But guess where we're going to be in exactly a month from now on July 27th and 28th? We are going to meet up a couple of hours north of where I am right now in San Luis Obispo, and we're going to be on the same panel together.
Yeah,
We're
yeah.
gonna
No,
talk
John,
about- yeah, good.
you may not be aware of this, but
Yeah.
this is being organized by the different California Tesla owner groups.
Right.
Tesla Silicon Valley and San Joaquin, and the person who's like organizing this thing, Kelvin Gee, he's like been organizing the whole schedule.
Right.
And what that means is basically we're going to be on the Kelvin timeline.
Sure it's not the Kelvin temperature? Could be one of the other ones.
No, it's
All
he's
right.
doing the schedule, so it's the Kelvin
The
timeline.
Kelvin timeline. Okay, before we start, I got to show you guys this because this is really cool. This is an Airbnb in Santa Barbara. And look, it's an actual geodesic building. So you can see like that pentagon and pentagram. And this, and if you look up at the ceiling, you can see the actual tiles. It is so cool.
That is cool.
Anyway, yeah,
That is cool.
if you want to rent it, it's just an Airbnb. So let me know. And
that's cool. I remember building like a fairly large geodesic project for my dad back when I was a kid, because he was doing this photography and they wanted to get rid of the shadows, so these different things. And the geodesic is like kind of the perfect sort of setting. I remember getting these big pieces of cardboard that were definitely white on the inside and just sketching it. That was a cool project. Yeah.
Right. Well, there we go.
Like 15 or 16, something like that. So
Exactly.
but now to actually see the real one like that, that's neat.
It's really, it's amazing. And I assume it was built in the 60s or something.
And also
anyway.
like that's the science center of my school also built a portable one like that for doing observatories that you can bring into a classroom. Yeah, because it was portable. You just get the whole sections out and put them together. And so between that, but my dad's project and that, I learned a lot about geodesics. Yeah.
There we go. All right. So without further ado, let us talk about this picture. Chuck Cook asked, and so we said, yes, Chuck, we will do an episode on this picture here. Yes. So the basic idea is at present, it's 50,000, right? Yeah, 50 to 60,000.
Yeah. So they're thinking that 50 to 60,000. Yeah. Morgan Stanley's their estimate is 50 to 60,000 K per unit,
over here,
excluding software and other R&D kind of expenses. But what would the actual production cost of it be? And they make a pretty nice diagram here to break it down to. I sort of made a spreadsheet sort of like that, but not so clever with the diagram that way that puts it out there. Only two issues that I sort of have with the diagram. First, they misspelled camera up in the head.
Camara. Are you sure it's not a Camara?
Yeah, camera. And the FSD and chips are not going to be in the head. There will be cameras in the head, but the FSD computer is actually in the torso.
Actually, that's a pretty critical mistake that they made, because I saw battery pack and I assumed they meant battery pack plus the
So basically they're talking about the chips and everything else. So but they did a fairly good sort of breakdown of what they believe is going to be in the different areas for doing the shoulders. It looks like the counts are about right. And I would say where we have really large agreement is the cost is in the actuators. That's what's going to drive the costs.
Yes.
And depending upon what you're able to come up with the actuators, you'll come up with very different sets of numbers. If you take the actuators out, we agree, I think, very strongly with all the other numbers. So the battery pack they're saying is like $300.
Yeah.
I mean, think about it. I mean, that's nothing. That's incredible. It's like, so they've costed and realized, there's not a whole lot of batteries in there. That's going to be pretty simple.
Right. And I would say that the head, you have to take the board out of the head. Now the cameras are in the head.
Right. But if we look at what they're doing is for the bill of materials, the FSD, the chips, the cameras, it's not a bad estimate. What are they? Somewhere around 2,000. Okay. The FSD compute is like, I think it's $1,000 for it. Is it for one chip or is it for both?
The FSD in the cars, at least with hardware 3, and I think with hardware 4, it's around $2,100 was what Sandy Monroe cost.
Yeah, but I think that's for 2, and so I think it comes down to that. If you look at it, so and it's only going to have 1 in here, and then the other chipsets you have in there. Cameras are cheap, they're they're probably less than $100 a piece. They can probably get them a lot cheaper. So I think that's a pretty good estimate. Right around $2,100.
It is impressive that the battery pack's only $300 though. That's pretty amazing.
Yeah, and I think that's right. Now, when I estimated mine, I went high. I think I said 800 because that's what it would actually cost me to buy it from Amazon. I kind of priced it that way. And then it's like, well, there could be some other things because it's the batteries and there's the pack itself. But again, the production, high volume, the torso, it might seem as expensive, but you're just taking some aluminum and punching it out in a stamp and then putting it in there. And that probably also costs you less than $1 or something like that in material. So it's 300 is pretty reasonable for all that. So let's not go into the other joints right yet. They've got the other column down there, which is others. All the other stuff they're talking about that makes up the structure, everything. And that almost comes up to like a crazy sum of what, $500. And again, that's they might be on the low side of my estimates because I was again like, it's going to be a little bit more. But again, we're kind of in agreement. It's not a whole lot. When you throw all that stuff out, it's like, is it 1,000? Is it 500? It's just, it's a pretty low number that's there. So,
and I think what's important is to look at these percentages because you can see the hands, of course, are the highest percentage object because of the most complicated. But so if you want to do cost savings, obviously what you want to do is not approach the others part because saving 20% off $500 is nothing. But if you can save 20% off of $10,000, then you're talking. So
absolutely. Absolutely. Now, if you add up the others ahead and the battery pack, I mean, you're what, around $3,000, So that's what we're talking about is being kind of the low end, and then it just comes down to the actuators. And the argument has been okay, you've got I think 42 actuators now. If they're $100 a piece, that's another $4,000. So it's really hard to get to 10,000. When you're talking about that, kind of excluding maybe that the hands will be a little bit more than just the sum of the actuators, but there's a little bit more there. But again, you see, it's like, wow, we still have plenty of room to get to 10,000 if you can get the price of the actuators down around $100. Their estimates, they seem to be saying the actuators are probably going to be closer to about 1,000 a piece, probably. That's what they're looking at. And with a lot of the other stuff that goes into the actuators, that they're looking at sensors, it might be kind of complex, all these other things. So from a starting point, I am not going to disagree with them. I mean, they had to be conservative on these kind of things. And going through, and I think they are being very conservative, which means we can be very confident that sort of the high end of the cost of Optimus would be between 50 and 60. Pretty confident you could say that. And if you're using that for your investment thesis, that's a good place to start because that's still pretty cheap. I mean, it's okay. It's not cheaper than a Model Y or Model 3, but it's getting down there. And considering what a humanoid bot would be able to do, it's a bargain at that price. No
and let's also remember that this is very specifically Tesla's Gen 2 Optimus. So
yes, not the Gen.
And Elon said at the shareholder meeting that Gen 3 would come out, and that was the mass production, the one that they're really thinking about how to mass produce.
And that's the one with 22 degrees of freedom. Which means the costing of this is off. The hands are going to be a bit more complex, so you don't know what that is. At the same time, I'm looking at some things and saying, okay, the feet, their feet are pretty expensive. What's the feet coming in at?
$6,700.
I'm thinking like, what is so expensive about the feet?
I think that includes the oh no, that isn't the calves. Oh, you're right. Oh, that's odd.
No, you get the thigh motors and stuff like that. They're up there, and the mechanism that's down there is not a complex mechanism. It's not complex at all. So they're basically saying like 260 sensors, and it's like, okay, are 64 sensors that expensive? Now I'm not quite sure where they get the 64 sensors from. Whether they're just assuming they're in there. I haven't seen any place that says that that's what's there, except, there's a possibility it's there. And you could probably, you talk to enough experts, they'll probably say, yeah, there's going to be some kind of censoring down there. That seems like a high cost to me for just that on the feet. So I think they're a little high there. and just as they would be with, some of the actuators. Now, when we talked with Sandy about 2 months ago, kind of asked him, he was also up around this area that it would cost somewhere between this and even higher. He thought it might be closer to 100,000. And I think it's because he was like including the cost of software and everything else and amortization that he really thought that was the real cost. But then we did talk to him again a little bit later about the actuators. How much do you think would really be able to do these actuators? And we showed him the images of the real Tesla actuators. So he realizes that we're not talking about, simple little motors. And he was confident you could get that price down to like $100 or less. Okay. So I'm not quite sure we're saying to get the $100,000 and then the $100 for that. Because if you're getting $100, you're talking about 10,000 being in there. But to be fair to Sandy, I mean, he's not seeing the full engineering drawings and everything else, but using his gut from what he's seen and the cost. And the thing is, actuators can be produced pretty cheaply. I mean, you can go on to Amazon, you can still find a lot of actuators that are pretty sophisticated that are pretty cheap. Now, other people I've seen say that, well, these are not your run of the mill actuators. The power density they have to have in there, they're really, very state of the art. And I agree the design for these things might require a little bit, but a lot of times once you figured out the design, you'd be surprised how easy the production cost is, unless there is something like intricately difficult unwinding technology or something like that we haven't seen. I would think you should be able to do some.
But the one thing is, these were all obviously custom made because that's what they've told us. And so, the cheaper actuators that are out there are, number one, more mass market, so they're not as specific to this, so they're probably going to be cheaper. But also, just the fact that you're making this, you have to amortize the R&D cost of making these things. Is expensive, so it will take time for it to come down.
Exactly. And that's what we want to remind everyone is what we're talking about here is like the real cost of materials to go here into building. We're not necessarily talking about how much it costs to build a factory, all the R&D and everything else in there that has to be kind of factored in, but really looking at what are the material costs that would kind of go in here when you start running it and start doing the lines. The thing you say about the actuators is that while there's going to be a certain cost in the design of the actuators, at least in the Gen 2 bot, and I'm assuming in the Gen 3 bot, there's a lot of commonality in different actuators. So even though there's 42 actuators, there's really only 7 different types. 6 of the main structural actuators, and then for the hands, what you're going to have there. So that means they're only having to come up with the 3 lines. So that means for each bot, you've got way more than one of that particular actuator. So that means what it basically means is that like the green actuator that's there, I think there's 9 of those, the big green ones. If you sell 1 million bots, you need to produce 9 million of them. Okay, 9 million of them. That means, you can come up with a production line that's going to be pretty efficient.
Yeah, exactly. And it is possible that with the next generation, maybe they've reduced the number of actuators, not the number of kinds of actuators, by maybe 1 or something, so that instead of
or they may have increased it. They could go either way, because they may realize that from the standpoint of like power usage or something like that, they may realize that some of these actuators are over actuated just because we want to reuse it. And as a result, they have more massive than we need to be, and they consume more power. They're not as efficient. And they might be say, well, we're going to get more to kind of these families of them. There's another possibility that they may come up with like a combined actuator. That's what I'm kind of wondering if they would look at, actually, rather than having 2 motors that you snap together, really thinking it as like one unit that's housed together. And I think it was Boston Dynamics on their new Atlas bot. That I was looking at the back, and it looked like they did something like that, in which they had a combined motor unit that was able to provide 2 degrees of freedom in there. And so that could be a way of reducing cost. Wiring, it's like, it's like 1 wire in, 1 wire out with 2 motors. So there could be a lot of design changes in there that are very different than what we see. But I'm pretty sure they're moving the direction to reduce cost, not increase cost.
Exactly.
Based on what we see here.
But that is an interesting conundrum, because of course you want to optimize to be able to build as many of each of these actuators as possible. But also, if you're thinking about eventually building 100 million plus of these things, it really doesn't matter. Even if you're only building 1 per robot, that's 100 million of these actuators. So that's a lot.
And they're not going to build 100 million of of the
Gen 3.
Gen 3 or
Yeah,
even Gen 4.
exactly. Right.
They're going to learn so much from it that there's going to be
Right.
complete redesign, stuff like that. And then at some point, you're going to come up with one that's just going to be so much easier to mass produce. And it may be like, the way the Model 3 and the Model Y goes is that, every couple of months, it's changing a little bit, changing as they find some way to improve the processes.
Yeah. And even something like the Cybertruck and stuff like that is obviously being changed consistently under the hood, where there's things that they're updating and changing with every, especially the early versions. So
right.
Yeah, it'll be. So what do you think? Like, do you think that their target between 50 and 60,000? Do you think this is reasonable?
Oh yeah.
Do you think the percentage breakdown is reasonable? So that, like the hands and it's obvious that any place with a lot of actuators is the places where a lot of money is being thrown at it.
Now,
so yeah. Okay.
I would say the interesting thing about it is that, the bill of materials is pretty simple here. If we were to put a car in there, you wouldn't be able to show the bill of materials in one little slide like that. There's so many other things there. And, and as you could see, as we've always kind of pointed out, it's, these humanoid bots are a lot easier than you think in a way that I keep on joking that I can build most of it in my basement.
Right.
Except for like the FSD chips and stuff like that, which I have no way of doing it. Most stuff I can either pick up at the hardware store or, with the right kind of machine tools and stuff like that, knock out a lot of these things on your own. And so could almost anyone else. So it's not super sophisticated on what's there. It's just coming up with a way of being able to mass produce it really cheaply. It's, you just kind of go through, look at that bill of materials. It's all, again, it's the actuators, that's where all the cost is. The head, the battery pack, others is not anything. Again, I think they're a little bit way high on the feet. A couple of those things are down. So I'm confident that if they're saying 50 to 60, I'm not sure. Does that add up to 50? What they have there? Because they said 50 to 60. So I'm assuming that adds up to about 50. And then they're like, but we could be a little bit off.
A little bit of variance.
Exactly. So, and that's not including like the other amortization costs that are going to be in there. So, the first one's coming off the line will be more.
Like
the software costs and everything else.
But I think, again, it's worth reminding people that, very importantly, one of the benefits of building a robot that's smart is that these actuators don't have to have tolerances as tight as they would be if it was a standard industrial robot. Like, they don't have to be able to actuate to sub-millimeter precision, because if you've got a smart bot, it can adjust as it's moving and understand how to compensate for actuators that aren't perfectly aligned and perhaps go out of tune over time. So
absolutely. So smart compute will help. Not much more to say about it than that. It's more, let's say it's kind of nice to see that other people that are analyzing this are coming up with similar conclusions. And again, my conclusion is that, the cost is in the actuators. Right. And if you drive those costs down, the cost will go down significantly. And, it's quite possible eventually, there's some companies that just specialize in being able to produce these things to drive the overall cost down. That I'm pretty sure Tesla will do it in-house. I don't think they're going to go out because they already know how to build motors.
But let's say between Tesla and Figure and a couple of Chinese bot companies, they come up with really good actuator designs. The thing is that a Sandy Munro or somebody can take that, break it down, and then sell the plans to other people, and they can just make them. Yeah. So it'll commoditize relatively quickly.
There may be some. So I think a car has more actuators than a humanoid bot. You just think, it's just like the front motor and the rear motor. And it's like, well, you're forgetting a lot of other motors, the windshield wipers, the mechanisms for the lift gates,
steering wheel,
all that steering wheel. And then of course you got the windows and you're going on and there's lots of other different kinds of actuators, some that are very simple, some that are a bit more complex. Right. And Tesla might make some of those, but there are others that they're buying from a third party. So they're probably getting it from like Bosch or Rockwell or someone else that produces these little things for lift gates. So, it could be a company that just comes up with like the perfect mechanism for a hand and like it's undeniable market leader, just buy it from them. Don't worry about it. But the other stuff we'll go ahead. So that's always a possibility. And, we know Tesla is going to be buying the cameras from someone else. there's no need for them to do that in-house.
Yeah.
The
And
batteries,
course,
obviously, they'll buy from themselves because they know how to build batteries. And the question is, are they really buying the batteries from themselves? Are they buying it from Panasonic? It's not clear.
Yeah. Yeah. But and then of course also the brains, the motherboard and the chips and all that stuff will be made by TSMC likely.
But it's their
Samsung.
design. So
But
let's
it's their
remember,
design. Yeah.
it's their design, but the manufacturing, yes, because that is something that is very hard to duplicate. And, that's why I'm saying it's like I could build all this in my basement except for that.
Yeah, exactly. Yeah. Well, I mean, you look at that. You look at Stanford and several other labs have they're kind of clunky looking, but they can build these things for not that much money. And it's just a bunch of grad students hacking it out in a lab.
And Tesla was building, all those motors for the first and second generation of Optimus in-house.
Yeah.
And that was just some, and you can see, Figures also was producing their whole bot for the most part in a very small area in Sunnyvale. They just have some CNC machines and everything else. And I think Brett said that it takes them right now about a day to build an actuator by hand.
Yeah. But obviously that's going to be a lot faster eventually.
Yeah, it's gonna be a lot faster, but
once you get the design right,
but they're building it in-house. The thing is they're building it in-house,
exactly.
and that's just about all. So, motors have been around for like more than a century.
Yeah, exactly.
Maybe getting close to 2 centuries now.
Right.
And so we know how to build those things already. Just that this is a different type and for a different purpose. But I think in the end, people are going to look at it and say, it's really just not that much different than any other motor, except that you had a different set of criteria to optimize to. That's it.
Right. Yeah. Yeah. And which is great. I mean, ultimately, this is all to the good. It just means that what the unlock code, the cheat code has been, we need the brains and the battery energy density, which wasn't around 20 years ago either, right? A lot of these things had to kind of come together. But speaking of Sunnyvale and stuff, I have a lead on something rather exciting that might come up in the next couple of weeks since I'm out in California.
Good.
So I don't want to give it away yet, but I'm excited to potentially talk to somebody up there. So yeah. Anyway, thank you for joining me. I know it's very late at night on the East Coast. Don't forget about the X Takeover. It's the 27th and 28th of July. Big thing. Enjoy it. And Scott's going to be there now, and a bunch of people. It's going to be a party
on the West Coast. A lot people coming from all over the world. It's going to be an impressive light show. It's like a kind of almost a 3-day event, and there's something on Friday, Saturday, and Sunday. The light show is going to be very special. We know a little bit about what's going on, but we can't announce it. It's going to be a first time for that. And yeah.
Well, we saw a little bit of the same designer did the one in Muskegon. And it was pretty impressive.
Yes. But there's one more element that's been added to it.
Yeah. Well, can't talk about that. So it'll be exciting. I think that, I was going to say, I'm going to get into the 10-page Morgan Stanley report, but it's a little much to do right now. But there's a lot more information in that and some really interesting
right. And I think
some stuff
the rest
that I
of
don't
that
agree
is,
with, but it's also really cool. So
the rest of it is more like CERN's bailiwick in there.
Exactly.
And I think, where we kind of disagree is like what they think the numbers are going to be by like a 2040 or something like that. They're ridiculously low.
Yeah.
Absolutely ridiculously low.
Yeah, that's the thing is even they're saying, look how low cost of bill of materials this is. And then like, hey, why are you saying they're going to build so few of these things if it's going to be that cheap? And one of the important things in my mind, just to give a little preview of this, is the fact that they see very much fewer headwinds than for electric vehicle transition. And I agree with that. There's going to be much fewer headwinds to adopting humanoid robots. So that's going to allow it to ramp way faster.
Right. What they're and the reason they see it is because they're pretty much geofenced where they're going to be working in different factories and logistics.
Well, and there's not a lot of resistance from the incumbents. There aren't a bunch of gas-powered humanoid robots running around, which would be really loud.
And I think what they may be conservative because they may be seeing that these are going to be either augmenting labor or filling in gaps in labor, but not so they may be looking at the standpoint that if you have a huge number of bots, the economy gets so crazy that money almost doesn't make sense anymore, and you can't figure out how to even do your calculations. So keep the numbers low because we still need people out there working and earning a living and be able to afford these things, be able to do it. So I think that's what they're doing is they're trying to keep it into like normal economic kind of theory. Is that this is just something that's going to be a way to improve production and bring costs down a little bit. and then fill in some of the labor gaps here and there, and come up with a number that is below 100 million, which by 2040, which seems kind of small, but they're also looking at it more from industrial. I don't think they're looking at like home use. It's just like, because if it's going into homes, then it's going to be something else. And I assume that number, was that like a worldwide number, or was that just US alone?
I think that was Tesla's production numbers. I'd have to look at it
maybe
again, but I think that was their total.
All right, so maybe that's production, Tesla's production numbers, and maybe that's what it is kind of for the US market or something like that, and excluding the fact there's going to be these other companies, but they still say that's worth like several $1 trillion to the bottom line.
Well, that's where
of the company. So they're very bullish on it. And again, they probably don't want to put big numbers in there because they would be laughed at, of Wall Street. It's like, your numbers are just nutty. Just, we don't want to see. So like a more sober view, but remember, this is a very sober, conservative view, yet it's still very bullish. And
yet it's still crazy. That's the thing that's pretty cool. These are not hyperboles. These are actually Wall Street analysts. And so you expect them
that are being very, and respectively conservative. So, I mean, I would not say that they're like way, way, way off and have a big disagreement with them in any way.
Cool. All right, folks. Well, thank you so much for joining us with this. And I appreciate you taking time late at night on the East Coast to talk about this. Everybody let us know what you think in the comments and everything. And definitely come join us in July next month in San Luis Obispo, and we will see you in the next video. Thanks. Bye-bye, everybody.
Bye.